Safety is of paramount importance in a modern transport system. Wheel security on heavy commercial vehicles is of concern to operators and the general public alike. Nuts coming loose on wheels is a problem familiar to many operators of commercial vehicles. This video shows details of a series of tests conducted on the Wheelsure device to prove its effectiveness in eliminating the self-loosening tendency of standard wheel nuts. The tests were completed on a test machine, commonly known as a Junker's machine. In the 1960s, Gerhard Junker developed a theory as to why fasteners self-loosen under vibratory loading. Other researchers have subsequently verified his findings. Junker found that transverse dynamic loads generate a far more severe condition for self-loosening than dynamic axial loads. Any transverse movement which occurs between the joint plates will quickly loosen plain non-locking fasteners. To test his theory, Junker developed a test machine whose basic principles are shown here. An electric motor drives a cam that displaces a moving plate by a predefined amount. Such movement results in a loosening action, causing a loss of clamp force. By measuring this loss of clamp force during the test, the performance of different fastener systems can be compared. The arrangement of the test equipment consists of the test machine itself and a load cell indicator and timer. The timer allows the test duration to be set. A load cell is located under the sliding part of the machine to allow the clamp force present in the stud to be continuously measured. A wheel stud is placed into an adapter that fits into the load cell. The nut is placed onto the stud and tightened. In these tests, the nut is tightened so that a clamp force of nominally 40,000 pounds is present in the stud. To improve the visual indication of any nut movement, a white mark is placed on the stud and nut to indicate the initial tightened location. This test involves moving the top section of the machine that the nut seats on, relative to the fixed base, a distance of plus and minus 1.5 mm. The top section is moved backwards and forwards 12 times a second. The vibration is extremely severe and results in self-loosening of standard wheel nuts and plain nuts in general. Speeding up the video, the self-loosening of standard nuts during this test becomes obvious. As the loosening progresses and the nut rotates, the clamp force present in the stud reduces. The reduction of the clamp force present in the stud during the duration of the test can be measured and plotted on a graph. The clamp force with standard nuts quickly decays as the self-loosening progresses. By the end of the test, there is only a small proportion of the original clamp force remaining. The Wheelsure device is fitted to modified studs. The adapter has a left-hand thread so that when the Wheelsure cap is fitted, any rotation of the nut is prevented. The Wheelsure cap is fitted after the nut has been tightened. Testing of the Wheelsure device was conducted in an identical manner as the standard wheel nuts. The clamp force was recorded as the test progressed. Plotting the results on a graph allows the Wheelsure device to be compared with a standard wheel nut. The Wheelsure device retained 95% of clamp force in the stud. The 5% loss of clamp force occurred without any nut rotation and is due to embedding losses in the thread and under the stud and nut bearing faces. At the end of the test, the Wheelsure device could be removed, the device having succeeded in its function of completely preventing any nut rotation.